Lesson 6.2 is solving linear systems by substitution. Previously, you solved systems by graphing, and we found that the system solution was the point where the two lines intersected. No matter what method you use, if we think about it geometrically, the solution to a system is always where the lines intersect. But we do have another method, and this method is solving by substitution. So we'll take a little bit of a break from the graphing. There are actually 3 steps to using the substitution method. First thing you want to do is you're going to take one of your 2 equations in the system and you're going to solve it for one of its variables. Generally, up to this point, we've always solved for the y variable because we're putting equations in slope-intercept form when we graph them. But now we're going to choose to solve the variable either x or y, whichever one appears to be the easiest one to solve for. And it says here, when possible, solve for a variable that has a coefficient of a 1 or a -1. And again, we do that because those are the easiest ones to solve for. The second step is substituting. We're going to substitute the expression from step 1 into the other equation and solve it for the other variable. So if this first equation we solve for x, we're going to substitute that expression into the other variable or into the other equation for the x, and we'll solve it for the y. So that's what it means by solving for the other variable. And then step 3, you substitute the value from step 2, so whatever we get here, we substitute it into the revised equation from step 1 and we solve it. So I know this is very wordy, so let's go ahead and just look at an example. So here's our system. Y equals 3x plus 2. Hold on just a second. Sorry. Y equals 3x plus 2 and x plus 2y equals 1. So step 1 was to solve one of the equations for one of the variables. Well, looky here, this one has been solved for us. So we have y equals 3x plus 2. What I want you to do is get into the habit, I need to grab my tools, there they are. Get into the habit of putting this expression in parentheses. It's going to come in handy in just a few minutes. You'll see why. So there's step 1. Step 2, I'm going to solve or substitute this expression into the other equation. So now I'm saying y is the expression 3x plus 2. So I'm going to put that right in here, and I have x plus 2, and then I'm substituting in my expression for the y is a 3x plus 2. So again, this used to be the y. I'm making it 3x plus 2. And that equals 11. Along in step 2, it says solve it for this variable. So we're going to solve this for x. So we need to distribute the 2. So x plus 6x plus 4 equals 11. Combine your like terms, so you're going to get 7x plus 4 equals 11. We'll subtract off the 4. So 7x equals 7. Divide by 1, and I know that the x equals, or sorry, divide by 7, and I know x equals 1. So there's step 2. Step 3, it says now substitute the value from step 2, this x right here, into the revised equation from step 1. So I'm going to put this x right in here. So I have y equals 3 times 1, because there's my x, plus 2. So y equals 3 plus 2, which is 5. So my solution, I still want you to do an ordered pair. It's 1, 5. If you were to graph these, they would intersect at the point 1, 5. Let's do another one. Okay, here, not quite as nice, did not solve either equation. It doesn't have the x or the y, but when I'm looking at it, the coefficient here for this first x is 1. Remember back here it said it's a good idea, when possible, to solve for the variable that has a coefficient of 1 or -1. So my step 1, I'm going to take this equation, x minus 2y equals -6, and I'm going to solve it for the x. So I'll add 2y to both sides, so it's just one step. and x equals 2y minus 6. And again, remember, I want you to put that expression in parentheses. Step 2, I put this new expression in, I substitute it in, the other equation. So right here I'll substitute it in for the x because I'm saying x equals this expression. That's another way to represent it. So we have 4 times 2y minus 6, and then don't forget the rest of your equation, plus 6y equals 4. The reason we do this is because we can only solve these equations if they're in terms of one variable. And so now everything is in terms of y, and we're good to go. So distribute the 4. You get 8y minus 24 plus 6y equals 4. Combine the like terms, 14y minus 24 equals 4. Add 24 to both sides, so 14y equals 28. Divide both sides by 14 and y equals 2. And finally, step 3, I substitute this answer now into the revised equation. So back into step 1. So I have x equals 2 times 2 for the y minus 6. 2 times 2 is 4 minus 6 is negative 2. So my answer is negative 2, 2. Next one. I'm looking at all 4 of my variable terms, and unfortunately none of them have a coefficient of 1 or negative 1. So I just look to see which one does it look to me like the math is going to be the easiest to do. If I solve this equation for x, ultimately I'm going to have to divide by 2. And both of these numbers are divisible by 2, so that's great. If I solve for y, the same thing. If I look at this term, ultimately I'll have to divide by a negative 3, which is okay for the negative 33, but here I'm going to create a fraction. Not a huge deal, but a little bit messier. Same thing here. If I solve for this y, I ultimately will have to divide by 5, and neither of these are divisible by 5. So I'm going to take the first equation, and I'm just going to solve it for the x. No particular reason, just that x came first, so I figure I'll do that one. So I have to subtract off 2y, so 2x equals negative 2y plus 6. Divide everything by 2. And so x equals negative 1y, or just negative y, plus 3. Putting that in my parentheses, going on to step 2. In step 2, I have to substitute the expression in for the x. So I have negative 3 times the quantity negative 1y plus 3. And then again, don't forget the rest of your equation, plus 5y equals negative 33. Distribute the negative 3. So 3y minus 9 plus 5y equals negative 33. 3y plus 5y is 8y minus 9 equals negative 33. If I add 9, I get negative 24, and divide by 8, and we get a negative 3. Step 3. Now I substitute this answer back into the revised equation. So my revised equation is right here in step 1. So x equals negative 1 times negative 3, negative 1 times y, plus 3. Negative 1 times negative 3 is 3, plus 3 is 6. So the answer is 6, negative 3. Alright, let's do a couple application problems. We have the situation with the drumsticks and the brushes. So drummer's stocking up on drumsticks and brushes. And the wood sticks he buys are $10.50 a pair. The brushes are $24 a pair. He ends up spending $90 on sticks and brushes, and he buys 2 times as many pair of sticks as he does brushes. How many pair of sticks and how many brushes did he buy? So you want to put money together and you want to put totals together. So it's $10.50 For every pair of drumsticks, I'm going to use a D instead of an S because my S's look like 5s a lot, plus $24 for the brushes. And his total spent was $90. Now we have it so that he buys twice as many pairs of sticks as he does brushes. So that equation is actually D equals 2 times B. Drumsticks equals 2 times as many brushes as he gets. So here really is step 1. This equation in our system has D solved. So one of the variables is isolated. So let's go on to step 2. I'll substitute the D in here. So I have 1050 times 2B plus 24B equals 90. So 1050 times 2 is the 21. B plus 24B equals 90. When I add those up, it gives me 45. B equals 90. Divide by 45 and he buys 2 pair of brushes. And now step 3, I substitute the B back into my first equation here, my revised equation. So drumsticks equals 2 times 2. So drumsticks equals 4. So he buys 4 pair of drumsticks and the 2 brushes. And you know, if you plug this back in, it will equal $90 total. Last one, we have mowing and shoveling. Last year you mowed grass and you shoveled snow for 12 households. There's the total. You earned $225 for mowing a household's lawn for the entire year, and you earned $200 for shoveling a household's walk and driveway for the entire year. You earned a total of $2,600 last year. They want X to be the number of households you mowed and Y to be the number of households you shoveled for. So mowing plus shoveling equaled 12 households. And I know that for mowing it was $225. For shoveling it was $200. And my total amount of money made was $2,600. So now step 1. I'm going to choose the first equation because both of them have a coefficient of 1. I'm again just going to solve for x. So x equals 12 minus y or negative 1y plus 12. It doesn't really matter what order you put it in. Put it in parentheses. Step 2, I'm going to put up here. I substitute this expression in for the x down here. So I have 225 times the quantity negative 1y plus 12, and then plus 200y equals 2,600. Distribute the 225 and I get negative 225y plus 225 times 12 is 2,700 plus 200y equals 2,600. Combine my like terms, that's going to give me negative 25y plus 2,700 equals 2,600. Subtract 2,700, negative 25y equals negative 100. And if I divide by negative 25, I get 4. So this is 4, and this is y, and y was for shoveling. So we want to figure out how many households did we shovel. So 4 that we shoveled. Now I'm going to put that back in here. So I have step 3, x equals negative 1 times 4 plus 12. So x equals negative 4 plus 12 is 8, and these are 8 lawns that we mowed. Okay, I will put the assignment up tomorrow, so you're going to have to wait till tomorrow to do it. So make sure that you have your other worksheet done because we're going to check that in class tomorrow.